The confusing part in calculus is that you can relabel functions and you can relabel things. So first, let's just start with f, okay? Regular f, let's say f gives you an amount of something. And then if you take the derivative of f, you get f prime. And if you take the derivative again, then you would get f prime prime, okay? So this is normally the rate, okay? I'm going to write rate right here. This is normally the amount, and this is normally f double prime is normally your acceleration. Acceleration is the rate of the rate. Okay, sorry, I'm writing a little sloppy. I don't have my stylus, but so in this problem, they give us r, and they're saying that this is a rate. Okay, and also what clues us in about r is that it gives us units. It says megahertz per year. Okay, so that we know that r is a rate. So it doesn't say r prime, it just says r. So r of t is our f prime right now. Okay, that's our f prime. All right, so if this is the rate, then if we were to go backwards, we do the antiderivative, then we could say capital R if we wanted to. All right. Now, our problem doesn't use capital R, but I am talking about capital R so that you guys can relate it to the amount. If you don't want to write capital R, what you could do is you could instead write the integral of RT. This is capital R, okay? So this function is not the rate, it is the amount. The amount. Okay? Now, so what would that be in our case right here? If the rate is megahertz per year, the antiderivative of that wouldn't be megahertz per year, it would just be megahertz. All right? And this tells us that when t equals 4, the computers had a processing speed of 2500 megahertz. Notice it doesn't say megahertz per year. It's talking about megahertz. So the amount in our situation is megahertz. And if I were to try to relate this in terms of like writing it as a function, I would say that capital R of 4 equals 2500 megahertz. So now let's look at the question and what it's asking. It says, what does 2500 plus this mean? So for now, I want to ignore the 4 and the 7. Okay, we'll talk about the 4 and the 7 for a second. In a second. Okay, so 2500 would be R of 4. And then this guy right here would be R of t. Right? Remember earlier we said this right here is R of t. So both of these are amounts. It's saying if we started at 25,000 and then you add, which is an amount, it's the megahertz, and then we add more megahertz, what would that represent? Okay, now it's very important that we do consider, it's very important that we do consider our lower and our upper bounds now. That we understand that both of these guys represent an amount. So let's use some calculus for a second to see how we can rewrite this, to see if we can better understand it. If we did the antiderivative of r, we would get capital R. So we would go capital R of t, and we're going to plug in 7 and then 4. So we would go r of 7, and then we would minus r of 4. Okay, so we know what r of 4 is. R of 4 is 2500 in this scenario. And then we have r of 7. Okay, so what this says, if we recap, we're adding 2500 to the integral from 4 to 7. That's what this says right here, integral from 4 to 7. And what this integral from 4 to 7 ultimately gives us is the amount of megahertz at 7 and the amount of megahertz at 4, and it subtracts them. So what's the difference of megahertz from 7 to 4? And if we take this expression right here and simplify it even more, we would get these guys canceling out, and we'd be left with R7. So what does this guy represent? It represents the amount of megahertz. This is the amount of megahertz at 7, what's the units here? At 7 years. Okay, so T equals years. See, this is right here. T is time in years. It equals the amount of megahertz at 7 years. So now if we read each of these statements, we can decide which one of these this actually says. Like, what does it represent? The net change in processing speeds of computers from 4 to 7 years. Now that would be true. Now remember, net represents like a difference. Kind of like if you guys want to talk about gross income versus net income, your gross is the total amount of money that you make. Your net is what you have left over after you take out the deductions. And so if you're looking at net change, that's saying what's the change from R of 7 to R of 4. And to find the change, you just have to subtract the two. That's how you find the difference. Okay, so this is definitely not it because of this 2500. It totally changes the meaning of it. If this 2500 wasn't here, then this would have been our answer. Okay, the next part says, let's see, it says the average rate of change processing speed of computers between 4 and 7. Now the average rate of change would take this guy and divide it by 7 minus 4. That would take the average rate of change, right? That was a rate, because it would add all the rates of change from 4 to 7, and then you would divide it. Okay, that would find you the average. So this one is definitely not it either. So we know it's not this one. We know it's not this one. Let's read. The next one is asking for the average processing speed. That would be the megahertz. Not the average rate of change, but the average processing speed. That would have been from 4 to 7, capital RT dt, divided by 7 minus 4. Okay, so we know it's definitely not that either. Okay, then we reach our last one. It says the processing speed of the computers is, or when t equals 7, and that's exactly what we said before. That last one is our answer. I hope that helps. Please ask me questions in the comments if you're still unclear about something.